Let's solve one problem from JEST Physics. So the problem states that a particle of mass m moves under a central force Fr equal to minus k by r square into r cap. So its angular momentum is L and the total energy is negative. We need to determine the shape of the orbit and the closest distance perihelion it approaches the center. Closest distance it approaches the center. Okay, so we need the shape of the orbit. So the central force, effective potential, for a central force the effective potential can be written as, so for a central force the effective potential is given by V effective is proportional to the R minus K by R plus L square by 2m R square, right? So the total energy will be kinetic plus this effective potential. So the total energy we can write E equal to half m r dot square plus V effective as a function of R. Since the energy is negative and the potential is attractive, the orbit is closed and bounded, especially it is an ellipse. So since energy is negative and the potential is attractive, the orbit is closed and bounded. The orbit is closed and bounded. Specially it is an ellipse. So it implies that specially it is an ellipse, right? Show the shape of the orbit. Show now shape of the orbit. So the orbit under a 1 by r square force inverse square law. Show the shape. The orbit under a 1 by r square force, so which is inverse square law. Inverse square law is a conic section, right? For bounded motion it is an ellipse, the negative. So for a bounded motion it's an ellipse. So the general equation of the general orbit equation, so the general orbit equation can be written as 1 by r equal to mk by L square into 1 plus epsilon cos theta. So this is the polar form of the ellipse. So this is the polar form of the ellipse, right? So the closest, so is the closest distance. So now the closest distance perihelion, so it can be, so at theta equal to 0 we have cos theta equal to 1, right? So we have 1 by r minimum equal to m k L square by 1 minus e 1 plus e, sorry, implies r minimum equal to L square by mk 1 plus e. So where e is the eccentricity of the orbit, where e is the eccentricity of the orbit, right, determined from the total energy and the angular momentum. So the so our final or answer is the orbit is ellipse and closest approach is equal to closest approach is r minimum. So closest approach we can write as r minimum is equal to L square mk plus 1 plus e. So closest approach and the orbit is ellipse. Hope the answers are clear. So thank you.